Niles Burbank. I'm AMD's representative to the PyTorch Foundation, and I'm here today with my AMD colleagues Ian Nordeng and Robert Suderman. Ian and Robert, for each of you, how did you come to be involved with PyTorch?
I started with doing a lot of experimentation with sort of a lot of the large language models that were coming out, and we were looking into trying to be able to run them on smaller devices, basically consumer level hardware, and looking at compiling them down, so making contributions to a lot of projects to ingest these models.
And my background kind of started in the computer vision realm of things, where I kind of started in SLAM systems, and machine learning really kind of took off and took over a lot of those kind of classifier type of things. So I kind of learned and adapted to address those.
And you're both involved in work that involves MLIR and IREE. And for a generalist audience, maybe could you explain what MLIR and IREE are?
I mean, at its core, MLIR is sort of an extensible compiler systems. This is the way you avoid making the same infrastructure that you're constantly having to replicate for compilers. It's supposed to accelerate and also make it easier to have different compiler products interact with each other. And IREE is more of like an ML application to this.
Yeah, so basically IREE is built off of MLIR, so it depends on that, uses it. And ultimately, it's a compiler and runtime focused ML serving inference.
So what's the motivation for connecting those tools into the PyTorch ecosystem?
IREE really provides very front-end and back-end agnostic paths. So you can basically easily take something PyTorch-based or Onyx-based ML front-ends, compile that for basically any back-end target device. So it just makes sense to be able to integrate with one of the most popularly used ML libraries, PyTorch, and just integrate that with IREE and run on all of our devices.
It has like additional tooling for being able to do performance benchmarking, being able to actually determine where you're losing your performance and really get every dollar out of your hardware that you've purchased for it.
So can you talk a little bit more about the IREE infrastructure in the context of PyTorch, who that would be most relevant for as opposed to some other PyTorch workflows that might involve Triton?
So one of the advantages of it is that it's inherently it integrates well into the whole PyTorch ecosystem in a way that your full program can be traced and optimized. And whereas if you're going to actually implement something with Triton, you're going to have to understand how to write a GPU kernel and sort of take care of the actual tiling and data layout in order to get high performance. IREE kind of has an automated system to try to get that out of the box. The idea that you could take your PyTorch program, compile it, and improve your overall throughput without significant work by the developer. So this benefits more researchers where they're less interested in how to get high performance and more that they just want to get the highest performance they can out of their piece of equipment.
In the context of machine learning, does the IREE infrastructure benefit people who are focused on training, inference, or both?
It's really both. Inference, we're focusing on first to get the best throughput you can get, which is going to also help on the training side because inference is also used through that. But it's ultimately compiling a full graph, which training just adds to that graph and updates the parameters. So
one thing I wanted to touch on is PyTorch is obviously an open source ecosystem. A lot of AMD software work in the compute area is also open source. Can you comment on how open source has helped make possible the integration of IREE into PyTorch?
So most ML frameworks at their frontmost level are open source. So we can see this with things like JAX or Onyx or PyTorch. But as you get further into the pipeline, most people have been switching over to a closed source implementation. And one of the difficulties with this is that you can't necessarily understand where you're losing your performance because it's at that point behind where you can read the source code or you can modify it. With IREE, you're able to actually go and dump and understand where some particular kernel is significantly negatively impacting performance, and you can submit a patch and get this changed and improved. It ends up not limiting you so that if there is a particular case you've encountered, not only can you identify where that is, you can actually work with either us or entirely independent of us to submit a solution and produce a better version of the compiler.
So I'd like to ask now a little bit about the mechanics of how a PyTorch user takes advantage of these capabilities. What's necessary in order to use IREE with PyTorch? Is in the context of an AMD GPU or even in the context of other devices?
So we provide tooling that helps with that called IREE Turbine. It's basically a collection of tools to be able to use Torch directly through a compiled module or eagerly through Torch compile.
So to up-level it a little bit for somebody who might be a new PyTorch user, if I just follow the PyTorch installation instructions from pytorch.org, when I install PyTorch, at that point, am I getting the benefit of IREE?
No, we have it all open source, but it would be GitHub that you'd have to, with instructions to follow.
The majority of us, we actually do ship packages on PyPy for people who are familiar with it, such that it's just a couple of command lines installs and then works right with PyTorch once after each component's installed, which only takes a few minutes.
So it would be fair to characterize this as something not for the brand new PyTorch user, but for somebody who has a bit of familiarity with PyTorch and now wants to make sure they're getting the full value and capabilities out of the tool?
I would argue that new users can use it pretty well. It's mostly invisible, so it's only to make sure that the requirements are there, and once they're installed, it should just work entirely out of the box.
And we're constantly working on it and reducing pain points, so as we continue to develop on it, new users should see a more seamless integration.
So for somebody who is more expert and is looking to give back to the community or contribute to the project, is that something that the AMD maintainers are open to collaborating with other potential contributors on?
Absolutely. Everything, as we mentioned, is open source. It's open source first, so everything we do is available. People are welcome to submit patches and get code review and get that submitted. We also have Discord that developers actively engage with. And
I believe we still have a monthly community meeting as well. So for those who are interested in contributing to IREE, there's a meeting where if you have a major proposal or you just want to be able to understand what's going on, anyone's able to just join in and listen to what's going on in it.
So it sounds then like there's a couple of paths for somebody who's interested in contributing to get engaged through the community meeting, through the Discord server, or potentially by posting something on GitHub. So I know it's difficult to get one's head around all this just in conversation. For somebody who is interested in learning a little bit more about IREE generally, what's the best starting point?
We have a number of getting started guides, so we can basically demonstrate how you can download a model, compile it, and run it. We've done work on a lot of the stable diffusion models, which are actually like one thing that's particularly well known because you can have basically a piece of text go in and an image come out. And we do have running guides, I believe, for that still up and available, so they could download and say run SDXL on a piece of hardware and be able to generate images entirely end to end using IREE.
So if somebody wanted to start with, say, stable diffusion, what hardware would they need to have at their disposal in order to do that?
We support compiling pretty much all our devices, so long as it has enough memory to support kind of more memory-intensive models in that pipeline. Should be functional.
So if they had, for example, a typical gaming rig, would that be sufficient?
Absolutely.
So I've asked a lot of questions about IREE, partly because it's relatively new to me as well, but to turn it back on you, is there anything that I haven't touched on that you feel like the audience should be aware of or that you'd like to share?
I mean, the number one thing, and I'm more be a reiteration, but that like open source is largely the reason why this work can be successful. We take a look at most of this ML work going on, and it's being done in a sort of an open environment simply because we need to be able to actually get the most out of our hardware to be able to push these models as far as they go. In the last 5 years, we've seen a lot of these models go from like maybe a half a gigabyte to a gigabyte of coefficients to seeing ones that are 800, 900, even seeing ones that are pushing over 1,000 gigabytes worth of coefficients. And the only way that we really have a chance of being able to really support these models in a way that's efficient on so many different pieces of hardware we see coming out is by having people be able to engage in the open source community and being able to contribute improvements. They're very complex problems that really as many contributors can help with as necessary.
And did you have anything to add?
Another thing that it provides with that open source case is that since IREE does more code generation, we generate the kernels that are actually running on the hardware. You no longer have to have developers develop specific kernels for something like a matrix multiplication or for some specific shape. It really enables people to engage with and also help us drive performance across all of our devices.
So that I know has always been a challenge of extracting the full performance of the hardware without having to exert too much effort that's really specific to particular use cases, and then you find that the batch size changes, or you want to shard the model across a couple of GPUs, or the underlying hardware changes a little bit. So in any of those cases, does IREE make the developer's life easier?
Very much so. For things like changing batch size, it's basically just providing a different input shape to when you generate your graph. So it's very simple to generate that.
And one of the other things too is that one of the big advantages of how sort of like IREE and Shark works is that it ends up generating a known artifact that you can then run in the future. So you don't have to worry about a library updating and significantly negatively impacting performance. For anyone that's worked with like a lot of Python frameworks, if one thing needs to get updated, you often have to cascade update a number of other frameworks and discover that now you have a substantial performance regression. And this can make shipping a model in production really problematic, because suddenly you're not able to get your full performance that you had a few weeks earlier, and the reason for why is not necessarily you have something you have control over.
Okay, thanks. I have to say that just in the last few minutes, I myself have learned a great deal about IREE that I didn't know, say, 10 or 15 minutes ago, and I hope that's going to be the case for our viewers as well. So in closing, I want to thank both of you for joining me today.
Thank you.